Okay, so we did completing the square, and what we're going to do now is we're going to solve quadratic equations using the complete the square form. And what it's going to use is it's going to combine completing the square as well as the square root property. Because remember, when we had the completed square, there was that second power. And in order to get rid of that, we need to square root both sides. So let's go ahead and complete the square here. What you're going to do is you can either bring everything over to the left, or what you really need to complete the square is just the variables on one side. So it is up to you if you want to have it like this or you want the 4 on the other side. It doesn't matter. My preference is to just leave it like this and do completely the square. So there's a 1 in the front, so we don't need to deal with that at all. What we do need to do is take the 5, divide it by 2, square it. If I add it, take it away. Okay. The first 3 are always the perfect square. So these 3 right here. And then again, it always goes variable, sign, and then number, all squared. And let's go ahead and evaluate this one because it's not part of a perfect square. This is going to be minus 25 over 4 plus 4 is equal to 0. So go ahead and find the LCD here, which is going to be 16. So we get, 4. So the top is going to be 16 over 4. And if I subtract those negative 25 plus the 16, you're going to get 9 over 4. And the rest is going to stay the same. And since this was bigger, it's going to be minus. So to solve this, what you're going to do is you're going to bring the constant over. So you get this is equal to 9 over 4. Now, since we have something squared is equal to a number, we can square root both sides. And we get x plus 5 over 2. But the square root property tells us we need a plus or minus the square root of 9 over 4. And the square root of 9 over 4 is 3 over 2, because the square root of 9 is 3, the square root of 4 is 2. Okay. So let me go ahead and erase this top part so we can continue on. So x is equal to negative 5 over 2 plus or minus 3 over 2. So let's go ahead and add them. Negative 5 over 2 plus 3 over 2, or negative 5 over 2 minus 3 over 2. So negative 5 plus 3 is going to be negative 2. Negative 2 over 2 is negative 1. And then similarly down here, negative 5 minus 3 is equal to negative 8 over 2, which is going to be negative 4. So what I want to do now is show that this completing the square is really like a last resort sort of situation, where if you already know that you can do things like factoring, then you get the solution a lot faster. Now we haven't actually solved anything by factoring yet, but I do want to show you that we can already factor this left-hand side. So the factors here are x plus 4 and x plus 1. So remember, these two multiply together give you 4, and then 4x plus 1x is 5x. So if we wanted to solve these, what you would do is you would set each of them equal to 0 and solve for x. And that's it. So the entire solution here can be done in 2 steps. So completing the square should be the last resort if you aren't able to do this part, which we'll learn next time. Okay, so let's go ahead and do another problem. So again, the constants themselves don't have to be anywhere in particular. So I can bring over this -1 if I wanted to, or the +1 as a minus, and get k squared minus 4k is equal to -6. Now apply completely the square to that by taking the middle number, dividing it by 2 and squaring it, and then subtracting it. Now again, the first 3 parts is your perfect square. Variable, sign in the middle, the number 4 divided by 2. Bring down the other one, which is 2 squared, or 4, and then solve. So if I add 4 to both sides, you get k minus 2 squared is equal to minus 2. So k minus 2 is equal to plus or minus the square root of minus 2. So don't forget, if there's a negative sign on the inside of the square root, we can pull it out as an I. So this is k minus 2 is equal to plus or minus I square root of 2. And then bring the 2 over as plus 2. So in the other problem, we were able to evaluate the plus or minus. Here you cannot. So your answer is k is equal to 2 plus I root 2, and k is equal to 2 minus I root 2. Okay. And then you can leave it in that form because we can't evaluate. Okay. So let's do one last example, which is going to be this n squared equals 18n plus 40. So again, what you need to do is you need to bring the variables over to one side. So I'm going to subtract 18n to both sides. So I can have the equation as n squared minus 18n is just equal to 40. Once you have it like that, complete the square. So n squared minus 18n, plus 18 over 2 squared minus 18 over 2 squared is 40. And again, first 3 terms is always the perfect square. Variable, same sign, 18 over 2 is 9. This is 9 squared, so that's minus 81. And then solve. So add 81 to both sides. So n minus 9 squared is equal to 121. The square root on both sides will give you n minus 9 is equal to plus or minus the square root of 121. The square root of 121 is 11. So n minus 9 is equal to plus or minus 11. And here when we add 9 to both sides, we get 9 plus or minus 11. So very similarly to the very first problem, you actually have to evaluate it. You can't just write it as 9 plus or minus 11. So n is equal to 9 plus 11, which is 20, or n is equal to 9 minus 11, which is minus 2. So these are your 2 answers.